Okay, example 2. Thank you. The school claims that the mean is 10. All right, claim that it can complete an adventure challenge with a mean of 10. Thank you. Okay. The times needed by the students to complete is normally distributed. The moment you see this, you can therefore say that actually the x is normally distributed. Do you need to use CLT? No need, correct? X is normally distributed, X bar will be normally distributed, there's no need for CLT. Now this one, population variance of 2 squared minutes. Okay, just now when I went through with S3, there was quite a number of confusion. This is the units. It's not 4 minutes. This is the unit. The unit is minute square. Correct? Squared minutes means minute square. So the variance is 2. The variance is not 2 squared. Follow what I'm saying? The variance is actually 2. So you are given the population variance. Given. Population variance. This is given. This is sigma square. Make some notation to have this understanding. Now, random sample of 8 showed that they needed a total time of 86. What does it mean? That means you pick x1 plus x2 plus x3 all the way to x8, you get 86. So actually, x bar, which is the sample mean, is 86 over 8 from here. Make sense? Correct? Total is 86, right? But so you want the sample mean is 86. Now you're going to compare this value against 10, right? See whether the mean time is greater than the school's claim. So 5% level of significance, you want to see whether it's greater. Now let's do a quick recap of all the few steps that you need to do a hypothesis test. Let's do this part 1. First thing to do is to define. Correct? Define your mu be the population variance, population mean of x. Step 2. You define properly your H0 and H1. Your H1 alternative hypothesis is a one-tail test, is a one-tail mu greater than 10 because you want to determine whether the mean has increased. Got it? Step 3, level of significance given in the question. The thing is step 4, test statistic. Now, whatever I present in example 2 is all that you need to present, okay? Because example 1, I was a little bit detailed, where I draw graph, give you probability, etc. But what is presented here, all is the actual presentation. Now, when H0 is true, now this one is by the side, not really needed, but I just want to explain. If when H0 is true, does it mean then that the mean is indeed 10? It actually means that X follows a normal distribution with mean 10, variance 2. Am I right? If H0 is true, this is true. Follow? If H0 is true, this is true, it means the X bar should follow a normal distribution with mean 10, variance 2 over 8. Follow? This is from the previous chapter. Correct? If H0 is true, this is true, then this is true. If this is true, we use the test statistic. We don't use X bar as the test statistic. By convention, we usually use Z. If this is true, then X bar minus 10 divided by square root 2 over 8 is actually the standard normal. So therefore, we use this test statistic. Follow what I'm saying? You don't have to write all these, because over time, if you get familiar with this is quite natural. Follow what I'm saying? Good. Now, I don't know whether you recall, for decision making, we will use p-value to help us make a decision whether to reject or not reject H naught. Remember what is p-value? Can you remember or don't remember? Just very briefly, I don't have to copy, just very, very quickly. See, you want to do a one-tail test. This is 10, right? Then, this is 10. Then you got a value, sorry, this is one-tail test. This 86 over 8 is here, correct? It's about 10.75. 10.75. Now, this is the p-value. This is the probability of obtaining a value as extreme as the observed value. Correct? The smaller the p-value, the more evidence you have against H naught. One more time. The smaller the p-value means that the further this value is away from the mean, the more evidence you have against H naught. Make sense? Because you're saying that it's very far away from the mean, therefore you reject H naught. So therefore, we use p-value. Now, of course, you can calculate p-value, because if this is true, if it's like that, you can use your GC to calculate probability x bar greater than 10.75. Now, I'm going to tell you that actually the GC can help us calculate. GC can help us calculate quite immediately. The moment, all you need to enter are a few things. Now, look at the keystrokes here. If those of us who are faster, you can follow the keystrokes here, you can do it. The rest of us actually can follow me here. What you can do, stat, go to the right, you get this z-test. For now, we focus on z-test. Number 1, z-test. Okay? Once you see the z-test, you don't ignore this data first. I will elaborate in the following few examples. Let's go to stats. That means you're going to enter some statistic there. What is mu naught? Mu naught is what you want to test. That means in this case, you want to test whether the mu is equal to 10 or greater than 10. So you enter 10 here. Sigma, I want to emphasize this sigma is the population standard deviation. Let's go back to our notes here. This one that you enter here, this is the population standard deviation. You do not divide by root n. You don't divide by root n, okay? Because you are given population variance, population standard deviation now is root 2. Follow? Population, that means the standard deviation of x. Okay? Standard deviation of x. So, this one I put root 2. Now this x bar is the sample x bar, that means what you got, 10.75 or 86. You can actually just take 86, they will help you calculate, divide by 8. N is the number of samples, n is 8 in this case. Then you do your one-tail test, greater than, don't draw, just calculate. You get all these values. Make sure you can get all these on your GC. Got it? So, sorry. So you look, make sure you can get this screen. Once you get this screen, you can actually just, don't have to copy everything. I only need you to write down from the GC, the p-value is 0. 0.0668. Now this one you must write, okay, because this is a computation. How do you get 10.75? I need you to write this. I need you to write p-value, and you're good. So all I need from the GC is this magical p-value. I'm going to explain what each of the values mean, okay? I think 10.75 is quite obvious, which is what you entered, which your sample mean. N equals to 8 is what you entered, because you collected 8 samples. That's how you calculated x bar. Correct? What does z equals to 1.5 mean? Do you all know? I explain, okay? Okay, this is not part of the solution, but I just need to explain. Now, to calculate p-value, remember the bell curve I drew just now? If this is your x, this is your x bar. This is 10, is 10.75. This actually is your p-value. Now, if now this is z, I normalize it, z equals to x bar. This is in your notes, okay? You can copy away. Correct? Yes? Correct? Now, if this is 0, correct? The mean must be 0, for sure. What is, do we all agree that this and this are the same? Correct? I normalize it, I normalize it. So actually, the p-value is this value, where I take 1.5. This is 1.5, sorry. This one is actually 1.5. You don't believe, you calculate. 86 over 8, that means 10.75 minus 10 divided by root 2 over root 8. This 1.5 is the normalized value. Follow what I'm saying? That's what the GC help you calculate, 1.5. Correct? Then you decide whether that 1.5 falls in your rejection region. How do you calculate rejection region? Since your level of significance is 5%, then you will say, oh, okay, inverse norm 0.95, you get 1.6449. As long as 1.5 does not fall inside the rejection region, good. You do not reject it. Do you follow what I'm saying? It's all the same. So therefore, this probability is 0.0668. Whether you use this or this, you will always get 0.0668. But I just want to emphasize your GC obtained the 1.5 is this meaning. The GC help you calculate. So actually a lot of work is done by the GC. A lot of work is done by the GC. But we must understand. We must understand. Follow? All good? Can. Let's pay close attention to this one. This is our rejection region, okay? Correct? As long as my normalized Z value lie in this rejection region, I will reject H naught. Correct? But because I got 1.5, does not fall inside rejection region, I do not reject H naught. So, conclusion. We only use p-value. Since the p-value is greater than, that means it's not rare enough, you do not reject H naught. I want to emphasize that this one, can you please, is not sufficient just to say that H naught is not rejected. You must also conclude in context. You must, conclusion must be made in context. Okay, so therefore you say there is insufficient evidence that the mean time is greater than the school scale. All okay? All good? Okay. Let's take a look at part 2. Let's look at the question, the part 2. Part 2 says, now a random sample of 8, still 8, another 8, is taken and the sample mean is found to be x bar. So it is an unknown now. Okay? Cannot enter into GC, it's an unknown. Find the set of values of x to one decimal place for which the test conclude that the mean is greater than the school claim. So they are telling you this conclusion, you know. That means you know that the conclusion is H naught rejected. In part 1, you make a conclusion. In part 2, they tell you the conclusion, ask you what is the range of values x bar can take. Let's make the distinction, okay? Never mind. Now, therefore, I need to refer to this diagram again. Look here again. Now, in order for the conclusion H naught to be rejected, my Z must fall in this rejection region. Follow so far? So therefore, the first line I write is this. In order for the test to conclude this, my normalized Z value must be greater or equal to 1.6449. At this point, can we help our friends a little, those of us who are sleeping? Okay, I'm not talking to those people who are sleeping lah. You're sleeping, you cannot hear me, too bad lah, okay? But those your friends are, okay? Those who are sitting next to someone who is sleeping, okay? Please wake up. Alright. Now, then you ask ourselves, how do we get this normalized Z value? Remember, it is actually our sample mean minus 10 divided by square root 2 over root 8. Recall? Yes, that's the importance of writing the test statistic. Right, that's the importance of writing the test statistic. Then you want this to be greater than or equals to 1.6449. I don't think I need to say more because this is one inequality, one unknown. Okay, so I'm just going to give you the answer directly. Dot, 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 you get x bar to be greater than or equals to 10.8225. Therefore, the set of values you want, so therefore, in order for this to happen, x bar must be greater than 10.82 or 10.8. Hence, the set of values must be this. It makes sense, right? You want to reject H naught, your mean must be far away from 10. Makes perfect sense. Makes perfect sense. Okay. Look here. Now the question asks, explain what is meant by 5% level of significance. Wow. This is what I said last week. Can you remember? I'm going to draw a bell curve again. Don't have to copy, don't have to copy. I just really want to see. This is your rejection region, right? That means this is 5%, right? I say one more time. I don't know whether you recall. If H naught is indeed true, that means the mean is indeed 10. Your x bar could end up here, anywhere, or extreme values. No problem, because there is a chance. Rare that you will end up here or here, but it's possible. Now, the moment you end up here, you will end up rejecting H naught. 5% of the time, you will end up here, even if H naught is true. Correct? In fact, if H naught is true, 5% of the time, you will end up here. So therefore, 5% level of significance, I'm going to say first, see whether it makes sense to you, is the probability that H naught is rejected if H naught is indeed true. That means making a wrong conclusion. Follow? Correct? It is the probability that you end up an x bar here, even though mean is indeed 10. Because you do many tests, 1 test, 2 tests, 2, 3, 5% of the time you will end up here. Correct? If you end up here, you arrive at the wrong conclusion. So, therefore, you always, whenever they ask you for meaning of level of significance, you conclude in context. It means that there's a 5% probability that the test will conclude the mean time is greater when it actually is 10. When it actually is 10. Means in actual fact, H naught is true, but you made a wrong conclusion. So what's good? All okay. Must explain in context, okay? must explain in context means 5% level significance is a probability of the test concluding the mean time is greater than 10 when it actually is 10. All good? All right.